हेलो हेलो मैडम सायरा अनवर।
सर।
जी मैडम, आपको मेरी आवाज़ आ रही है?
जी सर, आ रही है।
ठीक है। तो आपके एंड पे भी कोई प्रॉब्लम तो नहीं है?
नहीं सर, ठीक है।
ठीक है, चलिए ठीक है, फिर इंशाल्लाह 2 बजे इंशाल्लाह पूरी शुरू कर देते हैं। आपने सब लोगों को मैसेज कर दिए, अपने जितने डिपार्टमेंट्स थे, लाइट डिपार्टमेंट्स?
सर, मैंने साथ हॉटस्पॉट भी ऑन की हुई है।
नहीं, वो मतलब जितने आपके जो लाइट डिपार्टमेंट्स हैं उनको आपने कर दिए ये मैसेज के वो पार्टिसिपेट करें इसमें? मोबाइल पे करना
जी।
था।
जी सर, कन्वे कर दिया हुआ।
चलिए ठीक है मैम। अच्छा, ये जो दूसरा है ये आईओट है, क्या पढ़ती हैं आप इसको? आईओटी पढ़ती हैं या आईओट पढ़ती हैं? जो आपके टेक्निकल
IoT।
लफ्ज है, आईओटी।
जी सर।
ठीक है, ठीक है, चलिए ठीक है, थैंक यू मैडम, इंशाल्लाह शुरू करते हैं।
सर, आपकी आवाज क्लियर नहीं आ रही।
जी, मेरी आवाज आ रही है अब आपको?
यस सर, आप ठीक है।
चलिए ठीक। Hello. Hello, madam.
जी सर.
Can you hear me?
Yes sir.
Okay. So, Bismillah Rahman Rahim. Assalamu alaikum. I welcome all the participants in our today's seminar. And as you know, this seminar activity is our part of our DAS event calendar, and it's carried out on every Thursday at 2 p.m. Our today's topic is on IoT sensor-based monitoring and management of water resources, and it is being presented by Engineer Saira Anwar, Lecturer, Department of Land and Water Conservation Engineering. So over to Madam Saira Anwar, please.
Thank you sir. I am Saira Anwar, a lecturer in Land and Water Conservation Engineering from Faculty of Agriculture Engineering and Technology. Assalamu alaikum to all. Thank you to being here. Okay. Bismillahirrahmanirrahim. Today is the 45th seminar of DS event of calendar 2022. My topic is IoT sensor-based monitoring and management system of water resources. As I introduced myself before, I am Saira Anwar from Land and Water Conservation Engineering and Faculty of Agriculture Engineering and Technology. These are outlines of my presentation or my topic. First of all, I want to discuss about what is the importance of monitoring and management of water resources. Then what is IoT, types of sensor regarding water resources monitoring and management, how IoT works, and what are the benefits in our field, specifically in the water resource management and training. First of all, as we all know, water is the main basic essential thing for all living things, and we can't survive without the availability of water. Due to the rapid development growth, population increase, and other circumstances, the water supply with many sources from the surface water or groundwater become too much low, and we can't compete with our requirements. So we have to switch to other options to compete it and did our work properly. According to different UN reports and other NGO studies, water scarcity will affect directly 20% of human population, and other percent also directly or indirectly affected. It is for the 2025, that is too much nearly years. Now we will discuss about the importance of monitoring, why we do that, and what is its importance. Smart water system can help the stop of prediction from happening. And undo the damage, the imprudent usage of water resources. As we are switching to the smart irrigation by using big data, IoTs, sensors, and artificial intelligence, we can undo these all prediction and we can delay our dangerous effects, and we can also restore our water resources as we are switching to less water required or precise water use. Then there is a time or delay, then our water source can be replenished or reworked. Water pollution is also a big threat for living beings, as healthy water and clean water is essential for the humans and also for the crops. If we can't provide healthy water to us, then it will damage our health and also our food. So which if we take unhealthy food, it will affect our health. So it's also essential to do its monitor its water quality, modern technologies to undo the effects, and we can use good water for others. Now, what is my point? What I am saying here, what is IoT? IoT stands for Internet of Things. It's a system of interrelated computing devices, mechanical and digital machines and objects that are provided with unique identifiers. It can be different things, sensors, are modules, or you can say humans, or devices which have identified are a particular unique ID, which can interrelate with our computer action, that's called IoT. For example, we are familiar with cars and drive it. We have sensors, built-in sensors in our cars which check our pressure of the tires, and then it will tell or give a message to driver to check the pressure, so driver can take positive implements or done positive works to implement on it. And for the kind of humans, a human person with heart implant device in it, it can be also IoT, because it is now interrelate with networks and give out his data to the other sources. This is the main system how IoT works. IoT is in hardware, and it works communicate its data with different processor, communication devices, and embedded software. It collect data, send it to the other requirement environment. From there, it can be processed, and we are get back our required results, and it will be implement and give our positive responses. This is the systematic diagram for how IoT works. Firstly, it will be start with action or object, at which point we are doing our work. Means suppose here is a human, we can say it will be a field with the soil, and here is many kind of sensors. As we have, humans have 5 senses, but sensor can have more senses than it. We can do any particular sensor which we want to done work with it. Here is a sensor which you can say, for example, it is humidity sensor. It can get data from the our device or our field to the humidity sensors. There, with the help of the Wi-Fi, IoT device, and other gateways, this sensing data is communicate with the aggregates, from which we can decide which kind of data we want to store and what implements we can do done on it. Through our IoT hubs and big data, this data is stored in our database, our SD cards, and any form of the data storage units. From where it is processing, we done its processing, which data we required and which working we required. Suppose, as I say, I am working on the field and humidity level, then it will check whether the humidity level or moisture content is optimum for the field. If yes, then it will give us message, yes, it will be optimum. It will analyze our R structures with using machine learning and stream processings, and it will say, yes, your data is fine, you can go for next readings. If its data is not fine, it can command us any other ways, means just you have to apply water in it, or you have to reduce water quantity. All these processes are done in its mind or its controller units. It will analyze, and these are shown in our screens. It can be a mobile screen, a desktop screen, or any other form. Not must we are have to visualize data. If we don't visualize, it will be work by itself. If after visualizing, it will take actions according to our commands which we have given it before aggregates, and it will act on our field, and this process is continually working. Then again, it will take readings, giving senses, communicate, aggregate, store data, process, and all the process is done again and again. This is the system, then how IoTs work properly. This is a simple example. These are, at this example, there may be different kind of modules we use for the sensors. It can be humans, devices, modules. It is specific with the sensors. These are different sensors which we use for collect different certain data, and these are gateways. Here is different examples of gateways: Zigbee, Arduino, desktop, and there are many other ways we can use for the gateway to process or to transfer data from one form to another form. Then this data will convey to the cloud, or you can say any storage unit. It can be database or web services. Both hands will work with the sensing data and work on them. Then web services will accumulate our data, work on it, process it, and make our required results, and then it will be displayed to us. Our mobile apps, our data log apps, or you can say our websites, or it will be directly, if we don't want to see, it will directly implement to the field which we want to do. Next, There are many types of the sensor for their optimum use, respective use. As medical science has different sensors they are using, or particular sensor which required for their working, and mechanical engineers have different sensors, agriculturists are using a different sensor, IT experts are using different sensor. But here I am just discussing about the sensor which are related to water resources. First of all, I am discussing about ultrasonic sensors. These are some sensors used for calculate or measure the water flow or level of water. I mean, how much water we have, to check our reservoir or to check our capability. It is just a simple example of one sensor, that is ultrasonic sample. These are other sample temperature and humidity sensors. Uh, these sensors are both work properly, and generally these both points are these both specifications and come in one sensor. This is one type of sensor, this that is DHT22. It deals with temperature and humidity, though both parameters. Next, this is just a simple ranges of two sensors. First is DHT11. Its minimum temperature is which it can calculate or measure is 0 degree centigrade, and maximum value is 50 degrees centigrade. And about humidity, it can work from 20 percentage to maximum 90 percentage, and its accuracy level for the temperature is 2%, and for humidity it's 5%. It can be positive or negative as it is the error or accuracy value. And on the other hand, I am discussing about DHT22. It's another sensor which deals with the temperature and humidity. Its values is just little bit good than DHT11. Its minimum range is minus 20 degrees centigrade, and its maximum range is 100 degrees centigrade. And about humidity, its minimum range is 0%, and maximum is 100%. As it is, its accuracy is 0.5 degree to 0.5% to 5% humidity levels. This is Psks sensor. It is basically used for check the quality of water. pH is the indicator in the water quality parameters. It will show the values of the positive or negative, means from 0 to 14, whether our water nature is basic or our water nature is alkalic, or you can say acidic. These are other parameters: turbidity, salinity, and EC sensors. These are essential for the checking the water quality. We have different parameters and different values for the our drinking water supply and irrigation water supply. From these sensors, we can get our data in real time, and it is easy for us to uh, continues our supply with optimum values of water quality. In the past times or in other hands, we are done these practices on the laboratories. For that work, we can't get the real-time data. We have to take sample in the laboratories, done work, then and after some time we can deliver our data, or then we can implement our works on the water quality. Whether it's fine or not, then we have to done. But with the help of the sensor, now you can easily work on the real-time values. Here is some example which are related to water resource management and monitoring. First, I am discussing with the smart irrigation management system. It's a sample, or you can say explanatory field, from which I can get data and work on smart irrigation application. If we can start from here, here are some pumps which can deliver water to our fields. From there, as it is a field of crop, so we must have to irrigate it. For these values, we know about its irrigation value or irrigation numbers, humidity levels, or whether we have to apply irrigation or not. For this purpose, we are using this application. First of all, if we start from this device, this is our management device, or this is a mobile. At here, I can get comments on it, whether I have to on my motors or not, and what is the climatic condition, what is the humidity level, and what is its chart says, okay, whether it's doing good or not. It will transfer data. First, it will get data from the our field. It will check it. If it say yes, it is possible or it is necessary to apply water in the field, then it will give command to the IoT cloud. IoT cloud is a database. It can be in the clouds, or you can be it work in the hard drives, and process the information here. Then it will be work to our controllers, which give information by the microcontrollers and other Wi-Fi devices to our pumps, and commands are passed there, and they will deliver water. Pumps will on and all the water is delivered to the fields. From here, now these drones assess the thermal data from the fields, and again this all data is processed to through microcontrollers to the IoT cloud. There is analyzing the data and checking the values. Then again this data will pass through our mobile. From there we can see what is the present condition or real-time condition of our field, and about this our system can automatically give commands to our field or our pumps to deliver water on this basis. This is another example, as there are two main parameters in water resources. One is the management and second is the quality of water. This module is about the quality of water, how to ensure it, how we can done its value on the real time. First, this is the Arduino-based sensors from which we are getting data about the temperature sensor, turbidity, and pH sensor. And then Zigbee is a module to convey data to the other modules or to storage devices. From there, the machine learning languages or other modules will work on it, and our data is analyzed and show on our web-based applications. These are some benefits of IoT-based water resource monitoring and management system. First, as I have discussed before, this is very good for the real-time information. As the past times are in many countries, even in our country, we are taking test of the water through laboratories. That is not real time. It's time before, but and we have to implement after some time. We get our sample from field, take it to the lab, check its value by chemicals, then make its results and show whether they are fine or not, which chemical is reduced in it, with which mineral it requires, we then added it. But in our IoT systems, water is as it is passing, there are sensors, they are getting data about its pH value, about its EC value, turbidity, and other required parameters, and it will be implemented real timingly, and all the values are progressively showing on our screens, and we can implement it as the quality requires. Now, its second benefit, we can control and manage our water anywhere, anytime. As you know, before the times, here in our irrigation system, there is Varabandi system, which means every person has its own turn, specific turn when he can apply the water to his field. Maybe it is night or day, or in summers, it's hot time. But due to the IoT, we have no use to go to the land or our fields to apply water. We just operate our water through our mobiles, or by sitting at home, just checking the values from our mobile, whether it is required to give the water or not. Then you can easily require water. Maybe it's night 12 p.m. You are just sleeping, but your fields are irrigated by the help of the IoT. Now next, we can see our statistical data, means as a researcher and other field persons, this is very helpful for us. We can maintain our data, and time by time we are getting our data, and we analyze our data about how it's working, what is the future aspects, how our bank results. We can easily analyze, and we can predict about our values for 10 to 20 years. These all values will helpful to our irrigation systems and management of the water, and also it will help about the production of the good crops and good yields we can require through this benefit of IoT systems. And as from the alert system and notification systems, I am a woman, and also all person are living in the home are use motors to supply water to fill its tank, and many times it will happen you on the motor and forget about that, and water will flow freely. For this point, when your tank is full, there is a message on your mobile, you can switch off there. But also it will be switch on by itself without interaction with mobile. This is a big use of the IoT technology. I am just giving a just very simple example, but in many conditions where humans are difficult to be there, this system, notification system, is very useful for that. means in our nuclear working positions, in our sensitive labs. These all systems are very helpful to human beings. It will less the human interaction with the disasters or dangerous chemicals. It will also help out to making our alarms, means we can take fix our time, fix our schedule, our working before the time, many years before the time. Then the time will approach, it will be automatically done. You can you are taking record, because as you know, the database means you are taking the record and managing it. So if we have managed data, and you can easily command it for the further years, easily it will do work on itself. It's very helpful to eliminate the manual interactions, because it will be automatically work without human interaction. So this process will be easily done, and human interaction and the laziness from our side will be also reduces, and the labor cost will be also minimized due to this technology. Thank you for listening. I am very thankful to all of you. Any question from your side? It's very helpful for me.
Hello. The house is now open for question answer session. If anybody has questions, you can ask questions. If there are no questions, I would like to thank Madam Saira Anwar for delivering a very informative talk on the subject. And I would also like to thank all the participants for participating in today's seminar. Thank you.
Thank you, sir.
Sure.